Hey everybody, today we're doing definite integrals using the substitution rule. We're going to do two problems, here they are. They're pretty typical u-substitution problems. U-substitution with definite integrals is really exactly the same process as u-substitution for indefinite integrals. The only difference is that at the end, after you get your antiderivative, you got to plug in those endpoints and subtract. So first problem, integral from 0 to 4, x square root 16 minus x squared dx. We're going to want to use the substitution u equals 16 minus x squared. This jumps out at me right away for two reasons. First of all, it's an inside function. It sits inside the square root, and inside functions are good candidates for u-substitutions. Second of all, its derivative is a factor in the integrand, up to a constant multiple. So the derivative of 16 minus x squared is negative 2x. X is a factor in this integral. After you've picked your u, the next few steps are always the same. We're going to differentiate and then solve it for dx. This is going to let us substitute out not only some of the x's in that equation, but also the differential dx. Okay, so let's do it. We take out the 16 minus x squared, plug in the u, take out the dx, plug in the negative 1 over 2x du, simplify a tiny bit to get something we know how to integrate. Notice that I wrote x equals 0 and x equals 4 for the limits of integration. And that's just to remind myself these are x values, not u values. When I eventually substitute those in, I want to remember to plug them in for x's, not for u's. I anti-differentiate, raise the power, multiply by the reciprocal, and then take the u out and put back in the x's. So take out the u, put in the 16 minus x squared. Notice that I did not substitute in 0 and 4 yet. Those are x values, so I got to wait till I get x's back in the equation. Now I'm ready to plug in. I plug in 4, I get 0. I plug in 0, I get 1/3, 16 to the 3/2. The negative signs there cancel. Overall, I'm getting 64/3. Again, I can't stress enough. You have got to plug in those limits of integration for x's, not for u's. Common mistake. Problem 2. So we're going to integrate from pi over 3 to pi over 2, cosine theta over sine squared theta d theta. We're going to use u equals sine of theta for exactly the same two reasons as before. First of all, it's an inside function. It's inside the second power, the square function, there in the denominator. Second of all, its derivative is cosine. Cosine's a factor in this integral. Again, we go through the same steps all the time when we do our u-substitutions. After we pick our u, we differentiate and then solve for the differential that's in the integral, in this case d theta. Then substitute in. So that denominator is going to become u squared because u is sine theta. And then d theta becomes 1 over cosine theta times du. Again, I've labeled my limits of integration to be explicit about the fact that these are thetas, not u's. A little bit of simplification and an antiderivative. Remembering to take out the u and put in functions of theta before I plug in the limits of integration. Finally plugging in, simplifying a little bit, and getting an answer. Negative 1 plus 2 over the square root of 3, which is about equal to 0.155.